Happy day. I am RENUGA, Assistant Professor, Department of Mathematics, M.O.P College for Women. Today's lecture is on the topic Introduction to Testing of Hypothesis from the course Mathematical Statistics. So sampling. So what is sampling? Sampling is the process of selecting finite number of elements called sample from a larger group called population. Next is statistical inference. This is also a process of drawing inference about the population by doing the analysis on the sample. For example, so we want to check whether a pot of rice is cooked or not. So what we will do, we will take a spoonful of rice and we will check whether it is cooked or not. Here the pot of rice is called as the population, the spoon of rice is called as the sample, and the inference is the rice is cooked or not. Testing of hypothesis. This is the tool or the method to get the statistical inference. Then we will see the procedures of testing of hypothesis. First you have to set up the hypothesis, then you have to set up the level of significance. Depending upon the sample size, you have to decide which statistic that you are going to employ, then do the computation, then comparing it with the table value to do the conclusion. So these are the steps to do testing of hypothesis. Now terminologies in testing of hypothesis. Hypothesis, null hypothesis, alternative hypothesis, one tail, two tail test, type 1, type 2 errors, test for large sample and small sample. We will see one by one now. Hypothesis. Hypothesis is the assumption or a statement that may or may not be true, is always tested on information obtained from a sample. Formulation of hypothesis. So utmost care has to be given while framing the hypothesis. So it should be simple, clear and declarative, to be tested only on one relationship, must be measurable and quantifiable. Based on the existing literature and theories, we have to frame the hypothesis not on our ideas, our own ideas. Null hypothesis, it is denoted as H0. Null hypothesis, when we are comparing two means, there is no significant difference, that is null hypothesis. The hypothesis that are made with the intent of being rejected, generally done to show that there is no relationship between what we are comparing. Alternative hypothesis, it is just opposite of null hypothesis, is alternative hypothesis, and it is denoted as H1. So there is some significant difference, that is alternative hypothesis. Rejection of null hypothesis lead to acceptance of alternative hypothesis, thus stating that there is a relationship between two or more things. While framing the null hypothesis and alternative hypothesis, we should have clear idea about whether it is single tailed or two tailed. So what is single tailed? How can we decide whether it is single tailed? If we know the relationship, in which direction it goes, either it may be greater or lesser, then you will call it a single tailed. You have two types of single tailed, one is left tailed, the other one is right tailed. And if it in a problem, they are asking you to check whether they are equal or not, then it is called as two tailed test. Type of errors, type 1 error, when null hypothesis is rejected when it is true, null hypothesis accepted when it is false, that is called as type 2 error. Here one tailed, a diagrammatic representation, the blue it indicates the rejection region. If the null hypothesis gets rejected when value of a test statistics falls in one specific tail of the normal distribution. This is for the two tailed. Here it may fall on left side or right side, that is the difference between one tailed and two tailed. Type 1 and type 2 errors. Here is a table with an example. Truth, H0 is true. Decision, we are accepting H0, it is a correct decision. H0 is true, but we are rejecting H0. It is false, that is called as type 1 error, and we will denote it as alpha. H0 is false, decision accept H0. It is type 2 error and it is denoted as beta. H0 is false and we are rejecting H0, it is the correct decision. Now I have given two examples. For the first one, the patient is healthy, the test incorrectly says they are sick. It is called as false positive. For the second case, patient is sick, tests correctly identify the illness. This is called as true positive. Writing H0, H1 for one tail and two tail test. These are going to be so important while doing the testing procedure. two-tailed test. So, how to write? Already I have told you null hypothesis, there is no significant difference when you are comparing two things. So, mu is equal to mu naught, and already I have told you alternative hypothesis is opposite of null hypothesis, that is why you are having mu not equal to mu naught. Then left tailed, the parameter is less than a value, that is actually this is nothing but h1, that is mu less than mu naught, opposite to that is h naught mu greater than or equal to mu naught. Very similar, you have right tailed, h naught is mu less than or equal to mu naught and h1 is mu greater than mu naught. Classification of hypothesis test based on sample size. N is the sample size. If n is less than 30, we will call it as small sample, and when n greater than or equal to 30, we will call it as large sample. If it is small sample, we will apply t test. If it is large sample, we will apply z test. These two are called as parametric test. We have one more test, that is non-parametric test, when it is depend upon the categorical data, that is called as the chi-square test. Now, classification of statistical test based on sample size with a simple example, explanation with simple example, n greater than or equal to 30. So, it is the large sample, you have to use z test. What are the types you have? One sample is z test, two sample is z test. We can call it a single mean, difference of means also. Simple example, testing if the mean weight of 200 rice bags is 50 kilogram, that is for the one sample z test. Comparing pass percentage of two schools, this is for the two sample z test. Then the second case, here n less than 30, already I have told you if it is less than 30, we call it as small sample and we will use the test t test. Here there are three types, one is one sample t test, then independent two sample t test, paired t test, that is for the dependent samples. Example for each and everything. Is the average height of 10 students differ from 165 centimeter? How can you identify it is, you have to apply t test, here the size is 10. So, here less than 30, that is why we are applying t test. Second example, do boys and girls have different average test scores? Here we are comparing two different samples. So, I can say it as what? Independent sample, the second method you have to apply. Third example, comparing test scores of 15 students, this 15 tells you, you have to apply small sample test before and after coaching, the same sample we are comparing it. So, you have to apply paired t test, this is the dependent samples. Then categorical data, these two are called, I already have told you, called as parametric test, now non-parametric test, that is it depends upon the categorical data, that is chi-square test. There are two methods in that, one is test of independence of attributes, the other one is goodness of fit. I have given an example for the attributes, test if gender and job choices are independent in a survey. Then F test, if we want to compare the variability, then you have to go for F test. The example I have given, checking if the variability in product weights from two machine differs or not. Then next is ANOVA, where we are applying this ANOVA. If you want to compare more than two groups, then you have to go for ANOVA. Here two classifications are there, one is one-way ANOVA, the other one is two-way ANOVA. I have given an example comparing average marks of students from three different departments. Summary. So, test of hypothesis, already I have told you 5 steps are there. The first step you have to set up the hypothesis, that is H naught H1, H naught is null hypothesis, H1 is alternative hypothesis. I have told you when you are framing H naught, there is no difference, that is H naught. There is some difference, that is H1. Then you have to choose the level of significance alpha. This alpha is nothing but we are fixing the error what we can make, either 1% or 5%, that is why if you are choosing 1%, alpha is 0.01, if you are choosing 5%, alpha is 0.05. Then set test criterion, depending upon the sample size, you have to choose whether T, Z, chi-square or F. Then the fourth step, compute test statistic. So, you have chosen the statistic now, right, you will have a formula, appropriate formula, you apply that formula and find out what is the calculated value. That calculated value has to be compared with the table value to draw the conclusion, that is the last step, making a decision. Thank you.